I want to take the derivative of the inverse hyperbolic sine, and I'm going to do it in a way similar to what I've done with so many other inverse functions. That is, I know how to take the derivative of the hyperbolic sine of x. That's the hyperbolic cosine of x. And I'm going to use this to figure out the derivative of this, because I know that the derivative of the inverse function is always the derivative of the function. No, it isn't. It's the reciprocal of the derivative of the function with the other variable plugged in. So, same method. I'm going to take the hyperbolic sine of both sides. So I've got the hyperbolic sine of y is equal to x. Then I implicitly differentiate. So the derivative of the hyperbolic sine of y with respect to x is equal to the derivative of x with respect to x. I like to do the derivative of x with respect to x. That's easy. That's just 1. But the derivative of the hyperbolic sine of y now with respect to x is, well, if I took it with respect to y, that would be the hyperbolic cosine of y. But I don't want it with respect to y. I want it with respect to x. So the chain rule says multiply by the derivative of dy dx. And then solve for dy dx. Oops, not dx. Dy dx is 1 over the hyperbolic cosine of y, right? Pause here, ponder some import, right? The derivative of the derivative of the hyperbolic sine of x is the hyperbolic cosine of x. The derivative of the inverse hyperbolic sine of x is 1 over the hyperbolic cosine of y, because the derivative of the inverse function is the reciprocal of the derivative of the function with the other variable plugged in, right? Now, this is a completely unsatisfactory answer because I didn't start implicitly, I started explicitly, so now I got to get back to x's. And if these were regular trig functions, I'd probably draw a triangle right now, but they're hyperbolic trig functions, and I need to draw a hyperbolic triangle, and I don't exactly know how to do that. Believe me, I've tried. I haven't come up with anything satisfactory yet, but I can use some information because I have algebraic relationship between the hyperbolic cosine and the hyperbolic sine. Namely, that the hyperbolic cosine squared of y minus the hyperbolic sine squared of y is equal to 1. Right? For any input, cosh squared minus sinh squared is 1. So I can solve for cosh y here, that cosh y is equal to the square root of 1 plus the hyperbolic sine squared of y. If these were regular trig functions, this would have been 1 minus the sine squared, but with hyperbolic ones, you got a plus sign in there. That being said, cosh y, let's see, 1 plus sinh y. Well, sinh y is equal to x. So this is just the square root of 1 plus x squared. And so this derivative now is 1 over the square root of 1 plus x squared. If you remember the derivative of the inverse sine without the hyperbolic, the derivative of the inverse sine was just looked like this with a minus sign in here. But for the hyperbolic sine inverse, it's this thing with a plus sign. And the difference being the relationship between hyperbolic sine and cosine has the minus sign here. The regular sine and cosine had a plus sign there. So the only difference is that sign right there. So anyway, there's the derivative of the inverse hyperbolic sine.